Hello, and thanks for joining us for the DTALite and NeXTA Training Pre-Workshop webinar. This is a recorded version of the webinar offered June 23, 2013, and is made available online for future users and training workshop attendees. This is the third video in a series of 4 segments designed to introduce you to DTALite and NeXTA. In this session, we'll use a software demonstration to visually introduce you to NeXTA and DTALite and highlight its functionalities. To begin the demonstration, let's first show you how to acquire DTALite and NeXTA. You can visit the project development website at code.google.com/p/NeXTA. This is where we keep all of our information on the project up to date and offer you the option to download the latest release through the downloads link. We offer new releases periodically as we add new features and make changes, and we download these files in the form of a zip file. After downloading the zip file, we extract the contents of the zip file to a folder on our computer. This is where NeXTA and DTALite differ from typical software applications in that the applications are standalone software applications. They don't need to be installed, and they can follow you anywhere you need to go. In general, you don't need administrators' access to use them either. To open the programs, we just go to the internal release folder where we've extracted the contents of the zip file, and we scroll to find the DTALite executables and the NeXTA executables. You'll notice that we have both 32-bit and 64-bit versions. Generally, we divide these into multiple functionalities. The 64-bit version has more available memory for large networks. The 32-bit version is generally used for importing files and for use on older machines. First, we'll open NeXTA by double-clicking on the NeXTA executable. As you can see, the interface is kind of a GIS type interface. First, we'll load a network to get an idea of how the interface functions. So first it asks us to load any simulation results pre-existing. This allows us to, if we have a big network with lots of simulation results, then we don't have to load everything. If we want to make edits or just view, some information in the network. All right. After loading the data, we see a loading status window which shows us some of the summary information about the network and tells us the simulation results that are loaded, tells us all kinds of different information. As you can see on the left side, we typically have kind of a GIS type interface where we use layers to manage data in the data set. So we can use the check marks to turn off and on layers. So for example, I can turn off the links, I can turn off sensors in the network. Now if I want to move around in the network, I can just use the mouse to click and drag. Basically, this makes it very quick and easy to move around. You can zoom in and out with the scroll wheel, or you have pre-specified zoom in and zoom out buttons here at the top. We also use the toolbars for editing networks. For up here, this is our primary editing tools, where we can add nodes, and we can draw nodes between we can draw links between nodes. Now let's say I wanted to take a look at the new data that I just created in a tabular form. I can go up to the project menu and look at our network data. Now this visualization screen is actually this is our user interface for the data format that we use in NeXTA and DTALite. So we have multiple tabs for different data types, which are stored in different CSV files. within each individual table, so this is the node table, we can see a specific node and its control type, amongst other attributes. We can go to the link tab, look at specific links in the network. We can also make changes by double-clicking on a segment and changing a value. And we can save data as well. Also, there's an option to edit files externally in Excel, since these are CSV files. Now, the next step after you've looked at your network data, you might be interested in reading your demand data. So if we go up to the project menu again and go to the demand metadatabase, this is one of the ways we visualize this is one of the ways we can manage our demand data in the network. So we have a list of demand files that we load for this network. Each one has a specified format, a loading multiplier which controls how many vehicles are loaded in the network, and a start time and end time to specifically tell you when those vehicles are loaded in the network. If I select a layer, it will update the matrix internally here, which tells us all the trips made between an origin and a destination zone. Additionally, if we were to open the demand metadata file in Excel, this allows us to view all of the data in tabular format, and we can quickly change things here. Additionally, we can assign different demand types to different files. So for example, the HOV file or the HOV demand type here is assigned to a different demand type than the single occupancy vehicles. Additionally, you can also apply a demand loading profile where you can change the percentage of vehicles which load during a 15-minute time period during the loading time interval. So where is all this network data being stored? If you go to the File menu and you go to the Project folder, the Project folder is how we keep track of all of our data for a specific network. This folder contains all of the different files which describe the network. For example, we have input link files, node files, etc., etc. These are all in CSV file formats, and they follow our open source Data Hub file format. If I wanted to run the simulation with DTALite, we have the simulation button here in NeXTA. We can change the traffic flow model, and we can also change the traffic assignment method. So the traffic flow model is, as we described in the second webinar session, we can choose between different queuing models. We can also use Newell's model with additional options for emissions output and utilizing movement capacities. The traffic assignment method is primarily used or primarily adjusted when you may have different network conditions which require different types of testing. For example, the method of successive average, or MSA method, is the most common, but if you're examining a work zone, you may want to use a day-to-day learning method for assignment, where we'll switch a certain percentage of vehicles each day. So let's take a look at some of the advanced visualization functions within NeXTA. First, you'll notice up here at the top we have a clock bar, which controls the time within the simulation when we're viewing, especially when we're viewing the simulation results. You can see the time period in which the simulation results are loaded here in bold here. So let's say that I wanted to look at the volumes in the network. We can view different MOEs over different time periods using the options here in the MOE toolbar. Additionally, I can increase the bandwidths on the links to get an idea of what, or to better visualize the volumes at different time periods during the day. I can move the bar to a specific point in the simulation. If we zoom in, you can see that the bars are changing in widths, indicating that the volumes are changing over time. And traditionally, we increment these in 1 minute intervals in the visualization. We can also do this for density, where we can use different colors to represent different densities. We can also do this with speeds. Lastly, you might want to look at queuing, where we can turn off the bandwidths and get a better idea of what the queues look like in different areas, especially near intersections signals. Lastly, we also have the option to animate vehicles moving in the network. As you can see, as the time bar moves across as time progresses, the vehicles, the little green dots in the network, are moving across the links. So let's say you have your simulation runs completed, and you need to perform some calibration and validation. With our integrated data management tools, this is actually quite easy to do inside of NeXTA. So first, we'll turn on the sensor layer. All the green boxes in the network represent data on a specific link with a sensor record. If I select the sensor layer and right-click, we can view the sensor data table. As you can see, each record has a sensor ID number with from node and to node to assign it to a link, a timestamp, and a count value. We also support multiple types of measurements, including occupancy, travel time, speed, and so forth. Now this becomes even more useful because we can directly compare these observations from the field with our simulation results. If we go to the right-click menu again and open the validation summary plot, we'll generate a table and a chart with which we can compare our simulation results. As you can see, this is our simulated link volume on the left, our observed link volume on the right, and a 45-degree line drawn through the center to indicate the similarity between our simulated and observed volumes at different locations. Additionally, what's even more helpful is we can use the zoom to link function and select specific points inside the network. So as you can see, this specific link is a freeway segment, and we can it might help us point out bottleneck locations. It also helps to point out where we're overassigned or underassigned, and helps us to make more, or it helps us to speed up the calibration process a little bit. So now we've looked at some of the sensor capability, or the sensor data and its capabilities within NeXTA. Let's take a look at the path-based MOE tool. What we can do is, we need to do first is we need to specify a path by selecting the path layer, right-clicking at a node, and selecting a location to begin our path and a location to end our path. We can also add intermediate points if we need to. Once we've drawn this path, we open the path MOE table, and it provides us with travel time statistics for that specific link, or that specific collection of links, where each link is identified in the path, and we have a travel time we have an end-to-end travel time estimate over time in the simulation results. Now, this might be, alternatively, let's say we wanted to make a comparison over several paths in the network. We can import a pre-specified path dataset, which contains travel time, which may contain observed travel times in the network. If we zoom out a little bit, we can see each path in the network. And you can see the different travel time. These are simulated travel times in the network over time. We can also compare our simulated and observed travel times in the network for comparison. As you can see, some are better than others. In this case, we're comparing with INRIX travel time. The travel times in this dataset were imported from an INRIX dataset provided to us by the Portland Metro group for comparison purposes. Now, we can also export this file to a CSV file. This quickly allows us to make comparisons over an entire dataset. Let's say I wanted to grab this dataset here and make a quick comparison. As you can see, the simplified interface here with the CSV files quickly allows us to make comparisons and visualizations using these data available to us inside of NeXTA. Next, let's take a look at the vehicle and summary MOE data that we have available to us within NeXTA. If we go to the vehicle visualization interface, we can filter information about vehicles based upon different criteria. For example, we can specify an origin zone, a destination zone, a trip type, or amongst several other characteristics such as speed, the number of vehicles. We can also do sorting. So this is the group of vehicles. Let's see. I'm going to turn off the path data first. Turn off the nodes, the connectors. This will make things a little easier. So if we go to the vehicle visualization, we'll sort all of the vehicles by the number of vehicles in a path, or number of vehicles taking a trip between an origin and destination. We get some summary statistics such as travel time, distance, average speed. Once we have a travel or an origin destination pair, we have a number of paths used between that origin and destination. In this case, it's just one. But if we select that, that path is highlighted within NeXTA. Additionally, we also have several individual vehicles that are using that path. Now let's say we go to another path. In this case, we're going south from the center of the Clackamas County subarea. You can see that there's actually multiple paths used by the different users in the network. This is the primary path used, but we can also view alternatives. As you can see, many took the direct route, going slightly east or slightly west first before going to the freeway, whereas a small subsection went east instead, out to another freeway ramp. This allows us to make quick comparisons between expected route choice decisions for different areas in the network. For example, if I know that one area is quite congested during a certain time of day, I can go back and check to see during different time periods, setting the filter for different time periods to see how the route choice changes over time. Additionally, we can also look at summary statistics for the network using the summary data tool up here at the top. Now, we can this tool allows us to have direct control over the x-axis and y-axis. For example, the first thing it shows us is the number of vehicles by different vehicle types. But let's say we wanted to look at the travel time over different time periods. Sorry, this is total travel time. We need average travel time. So this is the average travel time over 30-minute or 1-hour intervals. Maybe we want to get a little more fine resolution. We'll get a 30-minute travel time, or the 30-minute average for a travel time throughout the network. We can also export this data out to Excel for recreation in it, or to recreate these plots back in Excel again. Now, after we've looked at some of these visualization options, what if we wanted to export data to this data out to Google Earth? We can go to the File and Export menu, and we'll export out in a link 3D KML file. So in this case, this dialog lets us customize the file generated for the visualization in Google Earth. Maybe we'll change the color field to be based upon the average speed. And it'll automatically regenerate the different segments for the color bands. We'll quickly reverse the color ramp so it's green and red. So we'll generate the KML file for Google Earth and open up Google Earth. So this is our network. So this is our network directly imported into Google Earth. We'll wait for the graphics to load a little bit. In this case, we're using default heights for each individual link segment. And as you can see, different links have different colors based upon their, in this case, we're using speeds, or their average speeds. We can also adjust the height in the network. So let's say we want to use what are we going to use? We're going to use the total link volume in the network. We're going to set it to 0.1 for the multiplier, and we'll generate a new link KML. So in this case, the height of the different link segments represent the volumes on the different link segments. You can see the freeway stands out through the middle of the sub-area network, with other paths nearby, mostly in the arterial network, showing much lower volumes. But we can still see most of the color codes available to us about the speed information. Additionally, we can also export our zone data. Say if we wanted to make a comparison between our demand data. So we'll set our multiplier for height as about 0.3 and generate our KML file. As you can see, or in this case, we're using the height field as the number of trips starting at a zone. So this lets us know, or this lets us visually see where our trips are, or where the majority of our trips are starting from, especially with external locations at the edges of our sub-area. But we can also see In the center of town, we have multiple zones with very large numbers of trip generation or trips being generated there. Additionally, we can also export this data out into other simulation applications like Synchro and vSim. If we go to the File menu, Export, we'll export our microscopic data. We have several options. We can export data to our quick estimation method tool for estimating signal timings with the highway capacity manual methodology. We can also write out the Synchro UTDF files, the universal traffic demand format files that we use to pass information into Synchro. If we click those, after clicking the button, it loads the folder with the CSV files describing the network. We'll take a quick look at the layout file. So this is the universal standard file that we can write out into for passing information back and forth with Synchro. Additionally, we can also use this UTDF file format with passing information to vSim. This concludes the third session of the 4-part recorded webinar. Please join us by watching the remaining sessions using the links below.